Hello, we're going to talk about zeros, roots, and factors of polynomials. Let's say we have p of x is equal to x cubed minus 2x squared minus 2x minus 3. Now, it's a cubic. We say that the zero of the polynomial, or the zeros, I should say, of the polynomial are the values that make p of x equal to 0. Right, that's just a term that we use. The roots of the polynomial equation are the values that are solutions for p to the x is equal to 0. So they're the same value, just a 0 is a value that just makes a polynomial 0. A root is a solution to the equation p of x is equal to 0. Just a subtle distinction we need to be clear about. And the x-intercepts of the graph of y equals p of x are the values where the graph crosses the x-axis. Now, in this particular case, one of the values is x equals 3. Now, we know that if x equals 3 is a root of the equation, or if it's a 0 of the polynomial, then we also know that x minus 3 is a linear factor. Now, here's a little technique. If we're going to find out, just as an exercise, well, if I know that p of x is equal to, well, if one of the linear factors is x minus 3, then we say, okay, well, that has to be x squared. This is kind of long division without doing the long division. X squared times x, I'll do it in red, x squared times x, that's going to give me x cubed, so that matches up with my first term up here. Now, minus 3 times x squared, that's minus 3x. But here I've got a minus 2x squared. So I need to do, the next one's going to be plus x. How do I know that? Because I've got to have a positive x squared. X times x is going to give me positive x squared. And then I've got minus 3x squared, so that's going to get me back to negative 2x squared. Now the final term, what do I have? Well, I've got in purple, I've got minus 3x, that's that one. And then, but I need minus 2x. So we've got an x here. So it must be plus 1. Another way to think about it is I've got a constant term in here of negative 3. Well, it must be 1 times negative 3. Now, that's one of the roots, or one of the zeros is 3. Now I've got x squared plus x plus 1. Now there's no real solutions to that. So I could then find, what is it, the discriminant is 1 minus 4 times 1 times 1. So the discriminant is negative, so it's going to be 2 complex solutions. So it's going to have one real, and 2 complex roots. Complex zeros in this case, we could say. Alright, so that's just a little bit of an aside. So in general, we come down to this thing here, which I'll put a box around. I'll zoom into it. In general, if p of alpha is equal to 0, then we say that alpha is a root if it's an equation where the p of x is equal to 0, or a 0 if we're just talking about the polynomial itself, or if we're talking about the graph y equals p of x, then it is the x-intercept of alpha. We also know that x minus alpha is a factor, a linear factor of p of x, such that p of x is equal to x minus alpha q of x, some other polynomial q of x. Right, similar to what we just did with the x minus 3, x squared plus x plus 1. So my x squared plus x plus 1 I would think of as q of x. That's just a bit of terminology. Now we can do various things with this. Find the roots of x cubed equals 7x. So this is an equation. It's an equation, so we find the roots. Right, that's the way to think about it. If you have an equation, then you find roots for that. So that becomes x cubed minus 7x is equal to 0. Factorize. Alright, so that's going to become, well, so x is equal to 0, or plus or minus root 7. So that's the solution. Those are the roots, or the solutions of the equation. Find the zeros of x squared plus x. So if I factorize this, well, I can't. 2 numbers that add to 6 and multiply to 10, well, there aren't any. So x is equal to, using the quadratic formula, I can't remember that. X is equal to negative 6 plus or minus square root of 36 minus 40, 4ac over 2a So minus 6 plus or minus, so that's going to be negative 4, so it's 2i over 2, which is equal to minus 3 plus or minus I. So those are the zeros. They're not roots because we didn't start with an equation. That's not an equation. It's just an expression. It's just a polynomial. So we say that these are the zeros rather than the roots, because the roots offers equations. The final one, well actually I'm going to do a couple. Find all. Now remember we did this for quadratic. Basically it's the all just simply means you have to look at every possible variation, which means you just multiply by a constant a at the end. So what we need to do is find, so we've got 2 and then 2 plus or minus I. So those are the three roots. So obviously if 2 is a 0, then a linear factor is x minus 2. Right, that almost goes without saying, I'll just state that. Then we need to find the quadratic with roots 2 plus or minus I. Now if we find the sum and product of roots, so find sum and product of these roots, of these zeros, so we're going to do 2 plus I plus 2 minus I, of course, is equal to 4. That's the sum. And 2 plus I times 2 minus I, that's going to be equal to 5. Right? 2 times 2, it's the difference of 2 squared. It'll be 4 plus 1, which is 5. So if we remember our quadratics, I can say that the roots, which 2 plus I, it's going to be x squared. I've got to get this right. It's negative of the sum, so it's going to be minus 4x plus the product. Now you can double check this if you really want to. You can sort of find out if you wanted to do a bit of an aside. For sneaky kind of 4 plus or minus square root of 16 minus 20 over 2. Okay, what's that? Well, it's going to be 4 plus or minus 2i over 2, which is 2 plus or minus I. So we get back to where we started, so that's my quadratic. So therefore, the polynomial with roots 2 and 2 plus or minus I should say cubic polynomial, is going to be p of x equals the linear factor, except I missed something, I'll need to leave space, x minus 2, the linear factor, times the quadratic real factor, because we don't want complex expressions, we want it to be real. So I don't want to just write 3 linear factors with complex terms in it. We try to avoid having that. We want a real polynomial, and to cover the word or, we just say a, and at the end I'll say a is a real value. Any multiple is acceptable as long as it's real. And there you have it. That is going to have, always going to have the roots, well, sorry, I should say zeros, my mistake, zeros of, see how easy it is to get the terms mixed up. They're pretty much interchangeable, but let's be kind of strictly speaking at this point. Okay, now try this one yourself with a quartic. Find all quartic polynomials, that's a typo, with zeros of minus 2. We'll get started off. All right, essentially we're going to do, it's going to be x plus 2, x minus 1, x minus 3i, x plus 3i, dot dot dot, and you will probably be able to finish that off. Now what we've got is first lot of exercise, exercise 6D.1. See how you go with that. A few questions are going to be pretty straightforward, and I've actually forgotten to do something in number 4, which is, well, firstly finish the question, but something that I did for the previous question, maybe you can think about that. Something to do with a constant, perhaps. All right, happy days. I've got another one on the next page, so check it out too.